Good evening. Good evening to everybody. This is Engineer Suraj Singh for talk on mathematical formation of formulas on worksheet. Title being Mathematical Formula Demonstration, Equations, Geometry, Shapes, Combination of Shapes, and whatever dates are there, various combination letters. Many videos I have shared with you regarding formalization, or you can say formula composition, or you can say apps on spreadsheet, a useful tool for calculations, you know very well, all of you. And I have some also worked on this after those videos, something. Previously we talked of certain equations that you can view here on this sheet, certain equations, and then which we moved on to certain formulas, trigonometrical issues, triangles, and various equations at random without any systematic organization. Later on we started formula or ordinary geometrical shapes, like ordinary geometrical shapes as you can see there, these being square, rectangle, then ordinary triangle, you can say triangles and equilateral triangle, and then followed by isosceles triangle, right angle triangle, circle, moving on to sphere, and then cylinder, followed by cone, parallelogram, and then rhombus, trapezium, symmetrical, non-symmetrical, polygon, which five-sided polygon, can say pentagon, hexagon, or can say seven-sided heptagon, then octagon, eight-sided, nonagon, nine-sided, decagon, 10-sided regular polygon, and later on combinations between various shapes like triangle and circle, and later on can say right triangle and square, and followed by triangle and parallelogram, then combination of right triangle and isosceles triangle and teeth round. These all were connected together, interlinked together, and then five polygon or pentagon constructed around isosceles triangle, followed by six-sided hexagon within eight-sided octagon, you can say, and then we moved on to pentagon constructed with eight-sided. I'll show you all these sketches. I'm just giving you previous references for information. Maybe I've gone through this. An eight-sided pentagon, a polygon constructed within 10-sided decagon, and then on to three numbers polygon, decagon, three number five-sided pentagon, etc. And like that, we followed many, and we want to, conventional, you can say formally designed swastik, cruciform, and combination of, Shakti, David Mark, and swastik cruciform, and Shakti, David, along with others, rhombus are there, and there's swastik one inside and six number outside it. This we did, of course, we did star sign and octa motif, followed by isosceles, followed by you can say star, and we then moved on to letters A, B, C, D, E, F, G, H, I, J, and K. We were till K, now worked on more than that, then L, M, N, O, P, Q, R, S, T, U, V, W, and of course then inclined A, circular B, curved C, curved D, and curved G. This I have worked post that talk. I'll try to show you certain current sketches for your reference so that you have clear idea of what I want to do. This is curved B, this is inclined A, and here is W, V, U, T, S. I'll develop curved also, not yet done. Then R, Q, P, here is O, N, M, and L, and before that is of course K, J, I. We have already shown this K, J, I, H, G, G, F, E, like that. We have already shown that D, B previously. So not to waste time on that, just coming to point, coming to focus, we'll do now K. We had discussed K. K was that it was discussed already in this shape, and we had taken proportional dimensions in terms of A, and we have decided about that. Now we are going to talk about L, and this is L. You can say this is L here, you know it very well. This is L. This is, area 1, area 2. This is 5A, this is 8A, this is A. In this proportion, we are going to take and put here a strip so that you don't confuse. Now what to do? We have this column area. We are taking a strip width as 10, or you can enter whatever value you wish to get answer from. Not necessarily use what I am doing. You can take your way. That's area 1 and 2. We saw there area 1 and 2. So area 1 is 8A into A, 8A vertical A with strip. And area 2 is 4A this way into A. And I taken full 8, so 4 is balance, 4 is left. So A. And sum of this you can say 8 into B, 6, 8, 6 this is, and B 6, 8, 6, which is this one. So you can say 8, I say 8A into A. 8A itself is A as well as it is another A. Area 2 is 4A into A. You can see that. Area is 4A. This is 4A into A. So this is here, I can say simplest one. So this is 4, sorry, 4A into A. These are added to this one. This areas 1 and 2. And now we say this is area calculation is over here. This is small, only 2 areas. Now we go to parameter. I am taking separately each area. Like I am saying 1, 2, 3, 4, 5, 6. There are 6 parameters, points. Let us see how many are there. You can say 1, 2, 3, 4, 5, 6. There are 6. So we'll take just dimensions. You can see dimensions yourself. You can first of all let us see what is that. It is A, 8A, 5A, A, 4A, and 7A. It's already there. So we can say, all right, we'll take this as A, 8A, 5A, A, 4A, 7A. Just for purpose explanation, I am taking them in separate cells. I could collect them in one itself, but it would be difficult to explain once you understand, when you know what I'm going to. Then I've already taken in advanced stage just in one cell, but here I'm taking in separate cells for purpose explanation to everybody. Now A, I'm saying this is A, this is 10 here. A, 8A, this is 8A, and 5A, A, 4A, 7A. I'll formalize it. This is formula B, this is formula, this is A, and this is 8B, this one, 5A, this is 5 into B, 686, and this again here, and this is 4A, 4 into A this, and this is 7 into same. So why say this over parameter sum of all these? So you can say sum of G, this is G, 86, and this is L. So all this is sum here, which is answer here is in this cell. We'll find parameter. It's so simple. Now we have got area and we have got parameter. Now we say we want 3 dimensions, or you can say extrusion. When we say we extrude it, it goes vertically in 3, or in short solid shape, it goes in. So we have parameter here, area there, we extrude it. Whatever value we can take in, no harm on that. We'll say volume first of all. Volume is, area into the surface, not surface area into the. This area is E68, it says E, here is total area in this cell, E68, and N, this is N, we extrude it, so this is what we get, volume. And now we say, okay, we want perimeter, surface area, which is both ends area plus perimeter into depth. Area is that, 2 into E686, this is E686, 2 into this, plus perimeter into M6 is parameter into depth. We get this answer. So this is the result. L is resolved. We got dimensions. If you want to take them separate square surfaces, we can take here itself. Say we want surface individual surfaces, we can do it. This is function. This gives you box as a function of each surface. If I take this 10 and multiply by height there, I get each wall surface area. It depends on your requirement. Just add one more row here, and you can multiply this, you can get this, no problem. But we have estimated quantity now. Now we go to letter M. Letter M. It is a square letter. All I have both ways I'll do, but this I think this is square M. We can say, hold on, this is gone beyond. So I'll take little this way. You see, this is M. I'll take this way also later on. And now I taken just for purpose of ease of calculation. So 1 area, 2 area, 3 area, 4 area, 80 and 90 like this. So we'll see how to handle this. We'll take this now. Let's go further with this M. So we'll say area square strip with the same area 1, 2, 3, 4. We have 4 areas. Area 1 is 8A into A. Area 2 is 7A into A. Area 3 is 7A into A. Area 4 is 8A into A. These 4 areas we have to work out. Now area 8A, this is 8 into B692 into B692 again. We got area A solved, then 7A into a 7, this value into B, this value same. Similarly area 3, 7A into A, and area 4, 8A into A. We got this. Now we have to sum up them. 1, 2, 3, 4, all. We get sum of C and F range on the same row. We get square meter area of this letter. Now we have to resolve, we remember this is B692 for this. So we can say now how many perimeter areas are there. We have to see that. That's an important point. We'll say first of all 9A, 8A, A, 7A, 3A, 7A, A, 7A, 3A, 7A, and 8A. This is, let's see how it is. You see, if you just see this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 positions are there starting from anywhere. You can say I started from say 8A. It says 9A. We started from 9A. 8A, then we go to 8A. So we can say 9A, 8A, A, 7A, 3A, 7A, 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 7, 3A, 7A, and then A, and then 8A. Like this, because it's 9A, 3A gone here, 6A, 3 and 3. So we are getting all these dimensions here. Just for purpose of arrangement, we can take in one cell also, but that will be difficult to understand. So 9A, 8A, A, 7A, 3A, 7A, A, 7A, 3A, like this. All these 12 points are there. Now we will put a value there, a value which is a variable. A, for example, 9A, 9 into B692. B692 will go everywhere. So you can say 8 B692, B692, 7 B692, 3 B692, 7 that value, 8 that cell value. Let me speak cell only because this is cell location can change. Then I can say 7 B7 location of cell, 3 location of cell, variable cell, then 7 location of cell, A location of cell is here, and 8A. So these are all, and we can sum of I and T range. Let us say we started from I here. This is I here, I, and it goes like this. You can say I can say it goes up to here T. So I and T. So it is, I and T 692. This value 620 according to this, and we are getting parameter here. Now we go to 3D, which is very important one because that's where we want something to know cubic content or square meter. And this is what it says. We can then the area D we have to take G92. Is just G area? Let us see. Yes, let us see G area or not area. G is area here, so that's okay. G into that value of cell will be something, and we can say here that this is here. G692 and V692. V is this value. This is extrusion value. V. So we get area into this value, and then if you surface area, if you want to know, surface area is twice and area this area which we got before, twice that area, not this area, that area before, that is twice G, that is end areas. So G is end areas here we have seen before. Again I show you G is end area here, this is end area. So we take twice of this end area here. This is twice of this end area plus U is here, parameter into V is here, depth. So we get this value, surface area is this much. How we calculate? This is very simple actually. So we got all these three values. So now we can just, if we want, we can put it in bold mode, no problem, and we can put that also in bold mode. That is parameter. That is parameter here. We can put in bold mode for quick identification with the quick pickup, and we can say here area is also this. We can put in previous case also. Practice here. This is here both bold, and we can say here, and we can go parameter here bold, and we can total square meter bold here. So we resolve this, right? This previous one case. So then we get, okay, I'm not doing this previously. We can do previously also, just for information. I'm giving you this now. Let's go to, we talked of K, the L, and M. Now we are going to N. N. This is N. Let us see N. How N works. This is your N, you see. This is N. You can see this is N. 1, 2, 3, 4 steps. Now area 1, 2, 3, 4, 5 areas are there. 8 is this depth, A is this one. So in this one, total is 9, so this is a 5, and the remaining is 4. So 8 says 3 is this one. 3, 3, 6, 1, 2, 3, 3, and 3, 6, 3, 9. So this is N like this. We will make later on like that also. I'm just giving you this N. So we can say how to do this. And we are now sitting on N. And now area still with the same. Area 1, 2, 3, 4, 5. 5 areas are there. We check 5 is right. Yeah, maybe this is 5 areas. 1, 2, 3, 4, 5. The 5 areas, and also perimeter how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 dimensions are there. Perimeter we'll see later on now. Let's see now. Area 1, 8A into A. Area 2, 3A into A. Area 3, 3A into A. Area 4, 3A into A. Area 5, 8A into A. We have 5 divisions, 5 areas. So we can say 8, B698, B698, 3, B69, B969. It means this cell value actually, not B69, whatever is this. Wherever this is located, we'll write that one. So it's say same 3, and this also 3, this also 8. So we have got these values of individual strips, and we can sum them up, and because sum C to G we got this value here, this value got here. So we resolved covered area, coverage. Now parameter 1, 8A, 7A, 3A, 7A, 5A, 8A, 7A, 3A. This is external dimension we are talking of. 7A, 5 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then it's 12. So we count to 12 there. That's what we are doing here. Now we'll see how it works. 8A, A same cell, so it's there. 10 same cell. A same cell, 7 same cells, 3 same cell, 7 same cell, 5 same cell, 8 same cell, and A, then 7, and then 3, then 7, then 5. Let's sum this all up. Sum J698 starts with J698 is here, J, and here is U. Here is U. This is U here. So you can say here, this is up to you. So this value is here. And this here parameter. So we got area, we got parameter. Now what do you want? We want the extrusion. Now this area, that is H. H is area here. H. This is area, you see this is area here. So we use value of H here. H into this value, this is in W. And also here with the parameter, this V value, 2H that, and we get parameter. So we got both values here in this case. And we convert, we got our parameters and area. So let us see 3D value and also see this parameter here bold, and this parameter, this area to be bold here. So this is what we are progressively going on, and now we'll see how to handle letter O. Letter O, which is not very difficult to comprehend. This is letter O. You can see that one. So simple it is. Just I put like square, but we'll change circle also will do. This is 1, 2, 3, 4 areas, and this dimensions here. That's what you say. So you can just see that one. So simple geometry of this. Hold on, please. I have to switch on. Switch on. So value O, you must have comprehended what I was saying here. Value O, this is 4 strips, and we have to consider each one. Let us say now area A 1, 2, 3, 4, 8 into A, 3 into A, 8 into A, 3 into A. 8 is vertical and 3 is horizontal because width is 5A. So 1A, and when it goes, so balances 5 and 3 inside. 8 is vertical, 3 inside into A. Balance 1, 5 minus 2 is 3. Right? So these are area 1, 2, 3, and 4. So this is 8, has space B is this one, and we get these areas similarly. And this is sum of C and F. C and F, we get this value. So this is your area domain. Then we go to parameters. See how many are there? 1, 2, 3, 4. External, I say. Then external is there 4. 8A, 5A, 8A, 5A. So this is 8A, this is 5A, this is 8A, this is 5A, and sum is J to M. J to M is down one here, and you can say external parameter is done. Then we go through internal parameter. You can say internal size. Internal, this is total parameter of all. In this case, sum JM, and this is JM. JM is here. Now we go to internal one, that is 6A, 3A, 6A, and 3A. So 6A, 3A, 6A, 3A, and this sum of this P and S. Now we have to combine this because we are using internal and external. So internal external is N and T. T is here and N is here. This is N, so we add. So the total both combined parameter is this. Now volume and surface area. 3D, this is value of variable. Volume is this G, where G where area stands. That's G where area is there. So we can say here, this is G into V. V is here and G is there, so we get volume. And surface area is twice, and area, as I said, so twice same G plus this value of U into value of V, we get these parameters here, and we can say total parameters is here. We can say an area, other parameter, area is here, that's here, area. So we resolve O as well. Now we go to P. P, this is what P is about, You can see how P is done, very simple. Just is like this, but circular also will do, the curved one. And this A, this is 5A, this is A. And inside is, because this is 5, this is 3 here. And this is 8, so 1 and 1, 2, you get 3 here. So 3, 1, 4, 5, and this balance is 3. This is what we have, 4 areas here. So we'll take into consideration 4 areas here for P. Sorry, it's in here. So we go to P. What we say now? P area, 1 area, 2 area, 3 area, 4 area. As usual, because we are taking similar dimensions, so this is 8A, 3A, 5A, and 3A. Of course, these are not exactly similar because this is P. So 8A into A, 3A into A, 5A into A, and 3A into A. So it's 8A into A. Of course, this is because this is A as well, and so with this comes twice here in the multiplication. Same thing for 3, same thing for 5, for 3. And we get sum of this C and F. This is C and F. Here we get this value. Now go to parameter. Go to parameter connection, What's a parameter? External parameter, external size we're saying. And of course, we say how it works. As 8A, A, 3A, 4A, 5A, A. Let's see how it's shown there. We'll see 8A, A, 3A, 5A, like this is shown, and inside is another one. So 1, 2, 3, 4, 5, 6 here, and 4 inside. So we can say here, 4 inside, we'll see this here, 1, 2, 3, 4, 5, 6, and value is 8A, A, 3A, 4A, 5A, 6, 5A. So 8A is 8A, 8, and this is 3 multiplications of 4 multiplications of 5 multiplications of the cell, and that one we get value of J to QO. So this is that sum up. Now we'll go to other one, that is other side inside the 3A, 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 3 all equal. So this, and this, and this, and sum of this is that one, R to U. So internal and external are both P and V. This is V, and I think this is P. So P and V is this one, expression is this, so we talk of 3-dimension mode. That's what we have to take. Now is 10, or whatever you can say, volume is here, that is G, that G is coverage here, that's here, and we may say G into X, this is X here, extruded depth, and we get this answer here. Area plus perimeter is also, what we say, that is, twice and area plus perimeter. D twice into G is there in area, W is here, that is inter parameters, and this X is that the extrusion, so we get this value. So we got this solid answers, and of course we get here area that we used here. That's what we did here. So this is where it happens, Now this is letter P. Now we go to Q, which is also very small but interesting one. Q, and this is what Q says, Q. I designed different way for purpose of calculations only, not necessary. We can curve it and do it. This is Q, Q. 5A, 8A, and this here, so 1, 2, 3, 4, and 5 areas. This is A, this is 5A, this is 8A, 5A, and because this is 8, so this is minus 1. This both are 7, and this is 1, so you can 6, 1, 7, 8, and internal is 3, and this is 8 minus 2, 6, like that it is. So that's what we say. Q will do like this now. Q. Area, we consider area 1, 2, 3, 4, 5. You see the 5 areas are here. 8A into A, 3A into A, 8A into A, 3A into A, 2A into A. These 5 areas, let's see how it works off. This is right or not, let me check it. 8A into A, then because I'm doing 8A, so this is 3A into A, this is not like this, so this is okay, 5 areas are there. So we can say fine. We have here 8A into A, this is 3A into A, this is 8A into A, this is 3A into A, this is 2A into A, and sum of this is sum CG. Here, that's the sum here. You can see we got the parameter go now. How many values are here? Parameter external 1 and internal. I think parameter 8A, 5A, A, 2A, A, 2A, 6A, 5A is what it says. Let's see what it says there. You can say here, external talking 8, 5, 3, 3 here, whatever it is, let us say it is again say external I'm talking. So this is 8, 5A, 2A, 2A, 6A, 5A. So 8A, 5A values are there. B 7, so 6. I'm not taking cell can be whatever it is, and 2 of that A, and this is A, this is 2A, this is 6A, and this is 5A. So we got values of parameter external one. So this is sum of K to R, and it is this one. We start from K, this is K, so K to R, this is this one. Now we'll say internal say 3A, 6A, 3A, 6A. Let's say here, 3A and 6A. So H there, 3A and 6A. So 3A, 6A, 3A and 6A, and value of sum of this U to X, this is value. Sorry, this is value. Now, internal and external, we say internal and external values. This is S and Y. This is Y. And what about that? S, we say this is S, so we get this value. Now we'll talk of 3-dimension. See, we can take extrusion value according to our requirement, and volume, this is because H is area here, we just confirm H is here now. This is H, that's area, that's confirmed, so we'll take as H into AA, and this is AA, and here we take total area, that's that is value of twice into end areas, and we have already seen twice into end areas, and that's twice into H, and Z something, Z is here, and AA is here, so we get this also. So you just keep it bold, just to see that we have checked it. Now we will do this here also, and that is area here, bold it. So we have gone through this. Again, I'm saying here we can add here some value for each extrusion, each wall extrusion or each side extrusion we can be done. Here what we do, we will multiply this value with extrusion, and we'll get each one. For that we have to take extruded value, and we have, for example, I'll show you how to do it. For example, I'm just showing you example, it's not necessary to do it. So I'll take little one here. For example, I say, okay, this value is here. I put this value here, let us say this value here, multiplied it by this value. So I say, I got it like this, right? So this can be done for whatever value. I'm just showing you a demonstration. So I go to Q is over, I go to R here, and this is R here. Of course, this is a little wider. I should say this is R here. So 1 area, 2 area, 3 area, 4 area, 5 area. This is 1, 2, 3, 4, 5, like this. External, this is internal. This is what we are going to do in this case as well. R. So area we have here, area, and we have variable width. A1, 2, 3, 4, 5, with 5 areas. So 8A, when I say 8A, this means 80 actually. It could be 70, it could be 100, or 200, depends on when you convert in terms of A, automatically it will change its dimension, size, and it will give real result. That's the purpose of this proportioning. It's a kind of not direct mathematics, but indirect mathematics. In proportional mathematics, you can say, or you can say some functional mathematics. So 8A into A, 3A into A, these are values I'm telling how we convert to cell values. These are, this can change. If you say I have 15, I change this, this will be changing already. So this is that one. So 8, this is 8A, 3AA, 5AA, 3AA, 3AA, and sum is here, C to G, and this is C to G, and that's the answer here. So you can say, I put this dark as well, no problem, bold one. We have now external and internal. Intentionally I did external and internal just for explaining purpose, otherwise it could be taken in one cell itself. So 8A, A, 3A, 2A, 3A, 3A, 5A, 6A, according to sequence of external or internal dimension, these A's have been taken. Not necessarily mix up, you just take according to the sequence, no problem. So this is 8A, this is A, this is 3A, this is 2A, this is 3A, this is A, this is 3A, this is A, this is 5A, this is 5A again, and this is sum of what? K, K2, K2, yeah, K2T. This is sum of K2T, and that's where K2T is, and we move to, this is your now internal. We're taking 3A, 3A is 3A, 3A, and because it's equal, so we say this is 3A, this is 3A, this is 3A, this is 3A, and the sum of this WZ, this is WZ. So we got this sum here. Now we have to sum up internal and external. That is U, and AA is here for internal, and that is U. Sum of all is here, that's for external. So we get this value here. And now 3D is here, which says that this value, area into depth. Area, we know this is H, we know H is there in this case, and this is H, which is area. So we get area here, and H into AC, AC is depth, and also we can say here twice, and you can say twice and area, and that area is H. Then AB is here as perimeter total, and here this is volume, perimeter into depth, and that is here twice area AB into AC. AB is here, AC is here, so we get both answers here, and that's where R closes. Go to S. I'm going a little fast because we have to say S, T, U, V, X, V, X, V, U, V, and W, and then we'll take spatial shape U. Let's say S now. S, T, U, V, W, A, B, C, D, E, D, G, etc. We'll take now later on, immediately after this. So it is, this is, we were doing S, I think. No, yes, S. We are doing S. This is S. S we are working on, which is, S. Where's S? Let us see how we designed S. This is your S, how it is designed. You can say, let me do it again because it has gone below that one. So let me pull it first, and then take other way so that other figure is clear. This is S value there, carved the not state one. This is 5 into 8 and 5A, A, because this is 8, so 1, 2, and 3 gone. So 5, 2.5 here and 2.5 here. So this is it. And then like this, we'll take its parameter as well. So that's 1 area, 2 area, 3 area, 4 or 5 areas are there. So we'll take them here, 5 areas. S. Area 1, area 2, area 1, area 2, area 3, area 4, area 5. What is that? Area 1 is a 5. You can see directly, you can see 5A into A. Then area 2 is 2.5A into A. Area 3 is 5A into A. 5A into A. Area 4 is 2.5A into A. And area 5 is 5A into A. So we just worked out cell wise from available cell of B, which can be any location for you. 5A into A. This is 2.5A into A. This is 5A into A. This is 2.5A into A. This is 5A into A. And total area is 1 plus 2 plus 3 plus 4 plus 5. So sum CG, which is this one. CG is that one, right? So that's here. Now perimeter, which is little more. But I'm going to, now this time, I'm not going to put them in separate cells. I just combine them, which is an interesting one because we have to do advanced work. Now, let's see how it works. Let's say, first of all, let's count how many parameters are there. Let's say I start with 5A. So you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 and 12, right? 12. That's how many? 1 here. Let us see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Hold on, just a minute. 5A, for example, here is 5A, 4.5A. This is 4.5A. Then 4A, this is 4A. Then 2.5A. Then 4A. Then 4.5A. Then 4A. Then 2.5A. This is this one. Then 4A. A. And let's see, is there something else hidden there? No. So this is all that. So let us see. 5, 4.5, 4, 2.5, 4, A, 1, that is 5, 4.5, 4, then 2.5, 4, and 1. So we have exactly this. This is both our complete parameters because there's no closure. So I just want to advance, so I included this in one cell. That's how it works. 5, 4.5, 4, 2.5, 4, and then 1, then 5, then 4.5, then 4, then 2.5, then 4, and 1. So we got this value here, total is, and now we concentrate on 3D. That is extrusion. D is this. And volume is, again we say H is cell where we say area is here. So H into J, that is this one. We got this. That's one part. And then we say 2-end area plus 2-end area is 2H. 2H here plus this parameter. That's this one. You can say I into J, and that J. So we got this requirement fulfilled, and this area, sum of area is this. So we resolved squared S, not curved S. I'm giving name like only means curved one where there's real letter. This is artificial letter. I said because I'm not taking curved one, I'm taking a straight one in this case. I will take curved one later on, just for ease because it's little difficult to make curve and then calculate. It takes the time, but I'm going to simplified one. So we move on to T. T is just available to you, very small, 2 areas only, and this is 6 wide and 8 deep. So you can say 2 areas only. In this case, area 1 and area 2. Area 1 is 6A into A. Area 2 is 7A into A. So this is 6A into A, and this is 7A into A. And that is 1 plus 2 total, and the sum of these two. Parameter is how many sides are there? 6A. A, we can this way that way. Then you can say 2.5 here, A, then 7, then 1, then 7, then 2.5. Also 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We got parameter just in one cell, accommodated in one cell, rather than keep it in the separately. But this will not give you an opportunity to calculate each wall separately. If you want to calculate each wall, each dimension separately, then you should put the 6A in one cell like that we did before. All is in 8. So it depends. If you want to just add that cells also, you can find that one. So we can say 6, 1, 2.5, 1, 2.5, sorry, 6, 1, 2.5, 7, then 1, then 7, then 2.5, and then 1. So we have this complete parameter. Now extrusion value. Extrusion is this area is, area here is E. This is E here. You can say E and G. G is that, then 2 and 2 into E, that's the sum area. This into plus parameter, that's this one. Parameter is this one, F and G is here. So we got these 3 values. I'll put them in bold, all these 3 values, so that you understand what's that. Now, I'll go to letter U. As you can see here, letter U is also small, 3 areas only. You can see them very well. I don't think I should blow it up. 1, 2 and 3. This is, let me just blow it little so that you can see comfortably. This is 1, and you can say this is 1, 2 and 3. This is 5 and this 8. And A is this, so A, then this is 8 here down, this is 5 here, so this is 3 inside, and we just move like that. So because they're very simple one, but simple or no simple, it's being done. So this is area 1, 2 and 3, you can say 1, 2, 3 area, and area 1 is 8A into A, area 2 is 3A into A, area 3 is 8A into A. So area 1 is 8A into A, area 2 is 3A into A, and 3 is 8A into A. And these are calculations for according to cell. So this is 8A, this is 3A, this is 8A. 8A into A, 3A into A, 8A into A. And total is 1 plus 2 plus 3. And C and E, that is C and E. And we get this answer of total. Now parameter we have to see. If you say how many, we just count them. 1, 2, 3 in between, 5, and 3 outside, 8. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 already here. So we'll see how to move on them. I just put them in one cell again. So let us say here A, you can see A there. In any direction you can move 8A, A, 8A, 5A, 5A, 8A, then A, and you know. So this is 8A. Oh, my mouse is not helping. What happened? Why mouse doing like this? Hold on. So you can say 8A, A8A, A8A, 5A, 8A, A7A, 3A and 7A. So this is what it's saying. So 1 here, 8, 5, 8, then 1, then 7, then 3, and then 7. So we got this parameter, complete parameter. Now extrusion, we have to see this. Area, where is area? Area is in F. So we'll see F into H. This is that one. We get answer of volume D, and 2 and areas, 2 into F, and G into parameter into this. So we got again same parameters, and this letter U is also over for volume, area, volume, and surface areas. Now we move to this time is 6, 9, so no problem, some time here. V is little, you know, I'll blow it up little better so that you can see clearly. V, and I'll just move a little better. V. You will be able to see this clearly now, or you know, V. I'll put a little more just for demonstration purpose. This is V. No, I dimensioned it here, but not necessary. Just this for purpose of proportioning. You can put whatever dimension you wish. Means all will change proportionally. You know, it will blow up. You go different dimension. You will accept whatever according to this ratio. According to this, in this case, I've taken 90 here, 80 here, but I put A here, which is basics. In terms of here, I'll change. For example, 90 will be 9, 80 will be 8, 89.4 shall be 8.944, 75.6 shall be 7.2, like this, and vertical here is 1.23A, and this is A. It's like that. For example, this dimension is 11, 18. I'll put a 1.118A. Same way, I'll do it. So let's now move further for its understanding, but this is complicated. There are area. How many areas are there? Let's look at that. Area 1, area 2, area 3. 3 areas are there. I've taken area 2, 1, 3, and then this total area. What is area 1? Trapezium. Which trapezium? That's what we have to understand. Now this is area 1. You know, there's a trapezium here, right? Area 1. And the area 2 is like a triangle. It's a triangle. And again it's a trapezium. So 1 trapezium, 2 trapezium, then a triangle in between. trapezium, triangle, and trapezium. So I am taking this trapezium. Trapezium is there. Size formula of trapezium is that this is 7.562A. I say 7.562. That's this dimension which I am taking in terms of A. I'll take this also in terms of A. So 7.562A is one side, 8.944 is other side. There is average of this or some division by 2 and multiplication by A. Similarly, area 2, this is a triangle half into base into height, and again I'm taking 1.236. Can say here this is 12 point something. I'm taking 1.236 in terms of A, and gives him this area 1 and 3 are same, so same equation. I'll put in there 7.562, this B value plus 8.944, B value half of this, and then this value. So we get this area, if you half base into height, half into base, 746 here, B, and this is height. So we get area of triangle, and area 3 is same as this area. So sum of this is C to E, and this is C to E. We got this answer. Parameter. Parameter, similarly we'll take parameter. How many sides are there? 1 and 1, 2. Inside to 4, 4 and 2, 6 and 7. 1, 2, 3, 4, 5, 6 and 7 we have. So 1.18 is here. 8, 1.18 this way, we can move anyway. 1.18 is here. Then you can say 8.9, which is here. Then A is here. Then 8 point something again there, then 1 point, it's 1.1 something, it's here, and then 7 inside something, 7.562, and then here. So we get this here. So we can say here, if you say 1.18, then 8.944, then you can say 1, and after that 8 something, then 1.1, whatever it is, and then 7.562, and then we got these here. From here to here, you can see each value is there, and we can say that this is where all these values are here. We go to this one, volume measurement, same formula. Area is there. Where is area? This is F. Area is F. So this is F into H is here. So we got this, and perimeter 2 into again F here, and G into H. G is here and H is here. So we say this information is also available here, and I will keep bold all these three. Now we'll move to W, that is, I did not take that one, which we will take later on. I'm just keeping in simpler mode, and that's where it is about. Is here 90 and 80, and this 3 vertical arms, and this is horizontal strip. Can say that this is 30, and this 30. So this is very simple. We may say 1, 2, 3 sides, then 4 sides, 7 sides, 7 to 9 sides, and 10 sides are there. So we will check it out how to do it. We can say area, only 4 areas are there. Just be sure 1, 3, 4, 1, 2, 3, 4. These areas are there. So area 1, 2, 3, 4. 7A into A, that's 1. I'm taking this 7 into, because this I'm taking 4. So 7, and 7, 3 7A's are there. Let's see. 7A, 7A, and 7A. 2 is 9A. So area 1 is 7A into A, area 2 is 9A into A, and 3 is 7A into A, 4 is 7A into. So this is that one. 7, this is 9, this is 7, this is 7. So sum is C, F, and this is that one. So we got this one, C1. Now parameter. We consider 3 sides and 4 sides, 7 and these 3, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. All on 8A, let us say 8A, vertical 8A, 9A horizontal, 8A vertical, A horizontal, 7A vertical, 3A horizontal, 7A vertical, A horizontal, 7A vertical, 3A horizontal, 7A vertical, A. So this is in line, this is in sequence. So we will put them like this. One cell, now taking on, we want to take separate cells, no problem, but I'm just squeezing it to one cell and filling every information. So this is 8, 9, 8, 1, 7, 3, 7, 1, 7, 3, 7, 1. And that's what is extrusion. We have to see where our area is. Our area is, total area is in G. So this is G into I. I is this. And 2 into, again 2 into G plus H. This is parameter and this is extrusion. So we have all this information available with us to and this letter also. So we have crossed W. We have crossed W, right? So we have crossed A to W now. X, Y, Z, I'm not done yet. It's easy. Diagram is ready. Figure is ready. Drawing is ready. But I have to work on that. I did not find time for that one. No problem. Now we'll go to a special one, a real one. A, B, C, and D, G. This I have worked till now. Let's go one by one to these letters. First we understand what is A. Already we have done, but this is different mode. And this is in fact real one, not apparent one. You can say, I want to say, this is according to requirement. This is A. You can read it very complicated, but you have to understand. If you want to, this is A actually. Is same dimension, but in inclination, not in rectangular mode. It's in real mode. So I have put many dimensions on this. These dimensions are only for purpose of analyzing, not for use. Means I'm not going to use the dimension, but this only for proportioning what we are going to do. Here is vertical 8A, and this is 5A. And here this is unit 1, this A. And these dimensions shall be converted. These angles are also given here for something, because we have to take all these dimensions are there. I'll divide them in terms of A. Means divisible, I'm keeping 10. This is A. This is A. So A is 10. Accordingly, all areas shall be divided like this. For example, 82, 46 will take 8.246. 34 area will take 3.48 like this. Everywhere. This is A, this is A. So we have area 1. Area 2 is small triangle in between because I want to make it a trapezium. Area 1, a trapezium. Area 2 is a triangle, quite. Area 1 is a trapezium. Area 2 is a triangle, of course, right angle triangle. Area 3 is here, again, a trapezium. This is a trapezium. There were one trapezium triangle, but here is a trapezium itself. So, area 4 is this trapezium. Area 5 is again same trapezium, symmetrical, and same way. Area 6 is same as 2, and area 7 is same as 1. So 1 and 7, 2 and 6, 3 and 5, 4. These areas we have to work out. Area 1, 2, 3, 4, 5, 6, and 7. And then also sides. We have these sides, these dimensions, and then internal here like this. So we have to do it now. Means, of course, its working requires little patience. You cannot just jump on something. We have to do with patience. It's very, very important. Patience is very, very important in such type of calculations. You have to do once only, and later on you need not put any input in that. Just use it. That's it. So let's say A. I have said for area 1, which says trapezium area, then it says I worked out in this here for this trapezium. Then area 2, which is triangle, I worked here in triangle, and it's 3 area, and then it's 4 area, and this 5 area, then you can say it is 6 area, then it's 7 area, and then total of all areas. And similarly, I put in various cells all these external and internal parameters, values, and then I did that way. So we go with patience on this side. This is detailed one, area 1, that is trapezium, which formula is AO2 plus base over 2. A here is 10, of course, this is unit. So because that is half 1 here, what I am doing is this. If you see this sketch, this I am saying full is A, but this trapezium is here. So A over 2 is here, that's why I am taking it over 2. And this we have. So what we do, A over 2 plus base over 2, right? Base is also there, which is 2. A over 2 or base over 2, That's what it says, this base. So, if there's some error, I'll calculate that, check, that's the problem, just giving a method how to do it. Into 1.88a, and what's 1.88a? That's point here, 1.88a. Let us see what's that. Once again, I blow it up so that you can little see this very clearly. This is 1.88a, and 1.88a, this is A over 2, and here it is, base over 2. When I'm saying base, it is this base. This is one dimension AO2, and this base which we have calculated, 1 according to formula, and that's why I'm saying this dimension over this dimension plus this, this half dimension of A plus this over 2, and then DAF. So that's usual formula of trapezium. So we are saying that this dimension plus dimension and half into 1.888, that's 18.81. We change it to 1.81. This is here 18.81 in this figure. We change this to there, so it's 1.881. This is what proportioning is, and this will change if you change A here. Now this is in 0.97A. When you base is this one A, this base here in calculation, not I'm saying right angle triangle. I'm giving details of that right angle triangle here. You see this value base over hypotenuse is equal to cos 14. If you see that triangle, again I'm showing you, trying to use, this is base of a hypotenuse cos 14 here. That's why I'm saying cos 14. So cos 14 base or hypotenuse cos 14 is the value of cos 14, and base, that is hypotenuse, that's in meter, and hypotenuse is, and that's the cos 14 value, and this is base is equal to hypotenuse cos value. We got this one, hypotenuse and cos value. This hypotenuse same as this value, so we got this value. This is area 1, so we got this base from here, so we got this answer. B, this is here, A over 2 plus, you can say 0.97 here, cos value. B, this one, this is a cos value, hypotenuse is that one, cos value over 2 into 1.881 into B sin 58, so we get this area 1 of trapezium. Now area 2 of triangle, a small triangle, but it's valuable. So for area 2, you can say perpendicular upon base is tangent 14 usually, and perpendicular is equal to base into tangent 14, and that's here we got this tangent 14, this value we got, and we got, you can say we got value of this perpendicular is equal to base into tangent. This is that value, and now area is equal to half into base into height. So we got this value half into base into height, and this is your value of perpendicular here. So this area 2 is also resolved. Now we move on to area 3, which is trapezium. Area 3 is a trapezium, and that is area 3. Let's see which area 3. What is area 3? Area 3 is here. Just for a clarification, this is area 3. We are considering this whole 4 sides. This this is 10A. This side. So this is this side plus this side is added over 2 into this one. We get value of 3. Area 3. So trapezium is 6.308. That is dimension wise. How dimension wise is that we are taking here 63.08, so 6.3, and also this one we are working out that way, so we get that one both, and we'll see how to do it. There's a plus and minus which you have done. I'll show you how they are done. So this is this 6.308a plus 3.48a plus 1.31 10.3a plus 1.546a. This is sum of many dimensions, because here if you see that, you will find this clearly. There's sum of that in these dimensions, which is this one, this and this and this, like this. This is the same. So this and this, I added up, find this value internal one, so that we can have both values clubbed together. So my dear, this is what I'm saying is, now we have gone here, area 3, this both sides, we have 6.3, this and this added, multiplied by a. So we half of this value into a, so we got this one 6.308 into b here, then 3.48 into b here, and 0.3 into b here, then this one into b here, and you can say this is over 2 into b75 again. So we got this value 3, area 3. Area 4, this is another one, area 4. This is combination of both, this is here, this area 4, this plus this into this, so we got that one. So let us see area 4. Trapezium is again 1.688a plus 2.188a, half and multiplied by a. That's what it says, 1.688a plus 2.1a, or half into b75. We got area 4. Then area 5 and 6, which are symmetrical to area 5, is symmetrical to 3, and area 6 is symmetrical to area 2. You can see clearly this figure says that 3 and 5 here, 1 and 7 here, 2 and 6 here. These are same, so we can say here area 5 as area 3, area 6 as area 2, area 7 is area 1. So 5 and 3 is 3, and this 3 is here, that is 758, H758. Then I758, this is I758, is sorry, it is H758, area 3. Area 3 is H758, area 6 is area 2, area 2 is F, area 2 is, G. G, area square meter is G, and that is, area 7 is same as 1, and this is area 1, that is here, area 1, that is in C. So we got all these areas entered, and total 1 to 7, all sum CL, and if you say sum CL, if you see, area 6, area 5, area 4, area 3, and this is area 2, and this is area, you can say, E, area calculation of 1, and that's this one. So we have to, you can say, let's see what is then. Total areas here, C to F. Actually, we should take one by one better. We should not confuse ourselves. So let's say one by one here. Let's say like this. Area 1, that is area 1 here. Area 1. Then we go to area 2, and this is area 2. Then we go to area 3, and this is area 3. This is area 4. This is area 5. This is area 6. And then we go to area 7. Area 7 is L758. I can write this L758 here itself. L758. We got this value. So this is that area, This is C58. All these 1, 2, 3, 4, 5, 6, 7 area. I will just verify. Area 1 is 7 C. Area 1 is C. Area 2 is this area. This is area perpendicular base into height, perpendicular base into height. Okay. This is area 2 is G, this here is G, and area 2 is G, area 3 is H, area 4 is I, area 5 is J, area 5 is J, area 6 is K, area 7 is L. So we got this one correctly. Now that's what about area. Now we'll see complexity of parameter as well, because parameters external and internal I am bifurcating. Like, let us see how it works here. As you can see in this figure, because this is not very regular figure. So we are taking this like 1, 2, 3, 4, 5, 6, 7, 8. Internally 3 here, and you can say again 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Internal is 3. So let us see how it works. How can we make entries? So 8.246, and then 1, 8.24, 8 is here. This is 8. We can say this way as well, or that is same thing. 1, 2, A. Then you can say, so let us see how it says, it works. Let's say parameter 8.246, say A, then 1.546A, then 2.11888 to 1.446A, and then A, then 8.246A. This is external. This is external. 1, 2, 3, 4, 5, 6, 7. Then we have internal, that's 3. So we have to check these values like this. This is 8 to 8.246, 1, then 1.546, then 2, 1.888. I like this. We got here sum of all sides, PV, and this is PV here, P and V. So we got this here, external, internal 3 dimensions only. So we got 3 dimensions here, all these 3, and we sum up here, YAA, we sum up here. So we got parameter, we sum of these 2 parameters. So this is V here, this is you can say V, I think, for first one, this is that one. So I think V758, sum of all sides, it should be W actually. Just a minute please. Parameter external is, we can say, total parameter external is W actually. This is, hold on, this is all sides, so this is W, this is W. So we got this corrected. So this is W, which is sum of all these sides. We can, that's what use of this is, means we can change as in required by editing. And now these 3 here, these 3 here is okay, these 3 are here. Now we'll say that in that previous case we are taken here sum of all sides, P, that is P to V. So it's here. Now this is W and this is AB. W and AB. So we can say W and AB. We got this now, W and AB. So we got this parameter, and here is area. M, is it area 1? You have to see. M is M, area 1. Area M. Yes, this is area, that's right. M is this one. So we got M here, and we can say that this is M into AD is there. So area is okay, fine. Parameter is, that is 2 areas, okay, fine. Now AC is this one, so it's fine. AD is this one. So we can say these 2 values are bold, and previously area is also corrected one. So we put this in this one. Right? So that is where complicated A lies in. I'll go to complicated B1, curved one. I'm calling complicated because it's real one. It's curved one. And this A was not curved, but A was not square one also. So this is B here. That's the problem. We have to move like this. So long step is there. So this is B here. You can see this is B. You see yourself how it's working, how it works. You see different dimensions here, very complicated arrangement, and it's all done on drawing and then posted here. So these are 1, 2, 3, 4, 5, 6 areas, 80 like this, and different dimensions are given. There are 3 curves on each. 3 curves, I mean to circular curves, not otherwise regular curves. This, if you take this A here, there are 3 curves here, middle one and internal one and external one, and this is curve here like this on lower portion, and here is, it's like construction of ladder. So I am given dimensions here, is this external radius, internal radius, and middle radius. In all these cases I have given these dimensions, which is very important. I cannot show you this time about AutoCAD, otherwise it's clearly mentioned in this. External diameter is radius is 12.5, internal radius is 12.5, middle radius is 17.5, and external radius is 22.5. Again, innermost radius is 12.5, middle axis radius is 17.5, external radius is 22.5. Based on this, we'll put these calculations on. So I'll now move on to calculations of B. We have area 1, area 2, 3, 4, 5, 6. 6 areas we have. You can say area 1 is 2.749 A into A. Area 2 is 6 A into A. Area 3 is 7.75 A into A. Area 4 is 3.834 A into A. Area 5 and area 6 are different because these are curved one, circular one, semicircular one, what we will say. Mid-arc length, I'm taking mid-arc length because this is sum of internal and external, so average of 2. The mid-arc length will multiply by strip width. So mid-arc length into A, where arc length is pi r, right? Pi r is arc length, because pi d is circular length, full circle length, half one semicircular is pi r. And then area 6 also mid-arc length multiplied by A, where arc length is pi r. And then we'll say total area. So now we see what we do. This is 2.749B. This is 6B. 6A into A, what I say, this is 2.749 into A. This 6A into A. This is 1.75 into A. This is 3.834 into A. And it's where it says that we have to be. And then area 5, just I'll keep this B again to you so that you don't confuse yourself. I'll be back when just you have a look on this better for clear understanding. I'm not in a hurry. This B is very important to be understood because here we are doing something different and we have to be clear first. What is required, what's not required, because it is different design. It's not square one, it's professional one, you can say. Because the professional in the sense we are doing exactly what B is drawn for. Just a minute. legs are actually jammed because of my fracture and operation. So I have to walk 5 or 10 steps to avoid sitting for more than an hour. So I have to actually walk a little. Sorry for that. Well, you must have gone through this arrangement of 1, 2, 3, 4, 5, 6 and A and B, sorry. And now, I'm sorry, where is B actually? Let me see, letter B. B here, yeah, it's still there. And you must have seen this. So, I can say here it's like that. B in its position, and we'll put here like this now. You must have gone through this. And now let's see how we do. So area 1, 2.7498, 2 is this, and so we are doing this. Well, this is no problem, 2.7949A, and area 2 is 6, A into A. Area 3 is 1.75 into A. Area 4 is 3.834 A into A. These are very normal. But area 5, area 6. In this I say pi r, let us say. Mid arc length, pi r. Mid arc length for purpose of area and for purpose of perimeter will take internal and external lengths, arc lengths. So let's say this is pi r. It's a semicircular area. I'm taking not full circle, so it is a pi d otherwise, pi r. Pi 1.753, B764 and B764, that is pi r. I think area 5 and area 6. Radius is, hold on, there's something. Hold on, just a minute. Pi r. What is r? Middle r. What is r here? That's the point here. R is, I should have written R here better. R is, let me see in my drawing so that it will be clear. R is, this is 1.75 R. Because I'm using A, so it should be 1.75 A actually. R is 1.75 A. That's what it says, 1.75 A. So it is pi, R is 1.753 A, B754. I am converting to that one. So in terms of this, it should be 1.753 and not 17, right? And then of course A is there, multiplication by A. So this value we get by pi r. And better I think I should write R is 1.75. So better, just for clarity, R is equal to 1 point, how much is that? Just a minute. R is equal to 1.753. Okay. R is equal to 1.753 A, so that it is clear, right? And in other case, R is equal to 1.73 A as well. Here also I will put this because we are taking middle arc length in both cases. So R is equal to 1.735 A. We'll copy it here as well for purpose of clarity. It's that one. Okay, so we'll say where is this and this one. Sometimes you miss so many things and we have to be clear about everything. Why it's not written? I don't know what's the reason behind that. It's there. Yes, it's there. Square mid arc. So what's that? Area 6, area 5 arc length into this and the everything. Area 6 and this mid is a arc length pi this and this. So this right is there. Right, no problem. So we got 1.75. Here also we got 1.753 B6 on. So this we got these arc lengths. And area we got areas 5 and area 6. So total area is from here to here but here we are taking rectangular and curved areas or arc areas separately. So this is total area, that is square meter, plane and rectangular either. So this says, you can say sum CF, and this is that area, squared area, and other curved is different, and this is curved area. This is curved area here. You can say this area is here, sum GH. Now we have to add these two areas for reference only, not for use. Using these two separately. So this sum of 74, these two, we get here I and J. This is that area. So what we say, actually, our areas will be considered separately. Squared areas here, that is square areas here, and the total area here, and rectangular area. Curved area is there. Total area square curved is here. Total area, this plane is here. Plane is here, and we can say that no. Plane, actually, no problem. PLAN should be no problem, spelling error. Plane area, then we can say parameter. This is our total area. Now parameter. In parameter, we are going to take external rectangular. You see, external rectangular and internal rectangular, and then we will take here external rectangular and the sum of external and internal rectangular. Also circumference, because we can't take perimeter in circle. So we have circumference called upper, I mean to say upper, and then lower, who are there. So circumference called upper, radial internal, radius internal, radius external, then circumference called lower, radius internal, radius external. The lower and upper we are doing separately here. Little expensive, and it takes time to understand, because you cannot combine rectangular and circular area together in plan figure or say. You cannot do that. So we'll say we have separate areas for square figure and for a curved figure, and it should be plain, plain area, rectangular. So we can say now we'll go to parameter. What is that? External rectangular. We are talking of rectangular. 2.7498A, 3.834A, because this is rectangular, not all circular is separate. So 2.749 is here with B, 8 is there with B, and 3.834 is there with B. So in terms of A, these are there, and we got these values, and the sum of these three sides, NOP, we are here, right? We have here. Now, internal rectangular. This was external. I'm talking of internal. 1.75A, 2.5A, 1.75A. So we got these values, and this is answer of this S, T, and U. Now, internal rectangular lower. This is upper. Why I'm saying upper? I'll show you again what is upper, what is lower. This portion, I'm calling this upper, and this is lower. This is rectangular area, this upper one, and this is lower one. Like this, I'm just trying to show this is upper, this is lower. It's that one. All right, just don't be confused otherwise. Okay. So this is that. So you can take your way. For my convenience, I'm taking this way, so I can understand. So external, internal, rectangular, plane parameter, Q, V, and AA. AA is this, and let us say what is Q and V. Let us say this is V, and here is, this is Q. So these parameters we have taken here. Now circumference is that one. Circumference. Because circumference means circuit parameter, not exactly. We can say radius is 1.25A, r equal to pi r. And radius internal external is 2.25A pi r. And we can say here that pi 1.25, this pi, this equals, and this here, and in this case it's here 2.25 this. So we got values here, 2.25b are that in terms of this, because there are two. One is 2.25, 22.5, one is 12.5, so that's why divided by a value. That's here we kept 10, so that it converts automatically. Now circumference curve 1, lower, same, it is internal and external radius is 1.25a and 2.25, so we get same here because radius up, down and up same. There's rectangular extension, not curve extension. Now we go to, now we go to, what's that? I don't know, total is there, was written here, let's see, I don't know what is this, circumference. Yeah, there's some raw problem. So it's there, all right. I think there's a sketch above, that's why it's not allowing. Because of this sketch, I think there's a problem here. Yes, there's a problem because of the sketch. The sketch has come up here. It should be there actually. So it's okay. It's okay. So I'm a little confused by this curtailment on dimension. So it's here. All right. So I say total circumference, and for that we have to understand this. This is, we have gone through this up to, and total circumferences. Internal is this, AD and AG. AD and AG. Right? External is this, AE and AH. AE and AH. We got internal and external. Sum of them is this. Sum of them is this too. Extrusion is, so this is 3D now, we'll see. We're taking separately this 3D issue because it's not that easy as you think, it's different. Now what we say 3D. Extrusion, volume cubic meter, plane area, and you can say plane area. This is again plane, I think should be PLAIN. By error it was written plane area. Area is the AL is this extrusion I764. Let me see where I764 is. I760HI. This is total area, plane area. So I. So this is I. This is I, and this is I764. Enter AL. So we get this, volume here. This is volume here. Now chord portion is this. Let's say that give two places decimals. Chord portion is this, and it says that J764. And what is J764? Let us see. J764 is total square meter area in curve. So J764 is this. J764 into AL. So we get curved area volume. This is that volume of curved area. We have got separate volume for plane and curved portions. Now rectangular surface area, that's where to find for rectangular plane area and curved surface area separately, because both items are different. So 2 into end area plus parameter into square, that's in case of rectangular area. So this is I is area, I said I is area. You can see I is area here, that is I area here, and this J area here. So we can say parameter, we have taken that connection. So I is strong enough here. We can say here, this is plane area, I into AL. So we got this, you can say volume of here, and we get here curved portion. This is J764 into, we got volume of curved portion as well as both volumes we got. Now we are talking of two end areas, that is this again I plus AB into this, and AB must be parameter. AB must be parameter here. AB, that is parameter external and internal. This is parameter here. So you can say this is parameter external and internal here we are using, and we are multiplying it by DAF. So we got this value. and that's okay. Now we say surface of circle. Again tan 2 into j as we said here in curve portion also we say j, so here is j again, and al is al into ak. Ak is there. AK is there, let's say circumference. AK, let's go and see what is that actually. AK is the internal external, so it's okay, circumference. So we got parameters. So hold on, I said AK, what I wrote there. AK internal external linear meter, it's okay, fine. This is circumference, it's no problem, it's okay. So we got this value here, that's fine one. So we have resolved B as we did. Of course, it is a little complicated, but complicated or not complicated, it has to be done. So letter C, we go now, let me save it first. So that if there is some change, it should remain. This is here simple, very simple. C, it's just the semicircular and little portion, 1 and 3, 2 is the semicircular one. I've taken again radius of these three, central one, internal and external, 30, 35, and 40 you can see, and then equivalent 10 or A here, two areas 1 and 3, and this is very easy, 5A and 8A like this. So let's work on these three areas. C. Let me see how it's working or no. Yeah, still it's working fine. So we can say C, and it is area 1, area 2, area 3. Area is 1 is a square one, this A into A. Area 2 is, that is arc length, A into arc length into A. So pi r, because it is semicircular. Pi r, not pi d. Pi r into A, and here pi r into A, and here area 3 is again A into A. So pi r into A. I think I should give value of pi r better. Pi r is there, 3.5 says, so let us see what value is there. R value, it says 30, 35, 35 is there, so we'll say R is 3.5. R value is 35, so we can say here, we can say pi R is 3.5, as we are saying, we can put here R equal to 3.5A. So simple, we can just for our reference, R is equal to 3.5A, so pi R, we got this, right? Arc length into A. Pi R is arc length, and R is 3.5A. And then A, you have to multiply with that. So like this, we say A into A. Here we say pi. Pi is here, 3.5. R 3.5. You can say, I should be sure also, maybe I made some mistake. Pi R is half, semi-circular circumference, pi R. And into A, if you say, so you can say R is 3.5, let's say pi, R is 3.5A, and then into A also, because that is 35, right? Maybe I'm sure or not, let me be sure. It is, let us say, yes, it is 35 here. This is 30 here, and this is 40 outside. So there are 3, 30, 35. R is big one here. R is big one, 30, 35, and 40, and I'm concerned with R is 35. So R is 35. Let us say 3.5A, R is 3.5A. So pi R is arc length. So we should pi arc length 3.5A. 3.5A, this is A. So this is arc length, and we have to multiply it by, because we are finding area to find this one, that's working, this one, this is that one, right? Oh, yes. Previously I missed A here. Arc length is there, be clear. Pi R is 3.5, A is this, into where that's A, so this is that one. Area 3, again same, so this is curved area, this is total square, total area, rectangular area, what's that, means this and this, you can see 7 C and E, C and E, this one, and you can, now you go to parameter, you have to go to parameter here, you define parameter as well. Now external rectangular, and I can say upper and lower, A plus A plus A, right? Why A plus A? You can see yourself. A plus A plus A plus A plus A. This is that. So we say A plus A plus A plus, so this is that, B side is all three. And total is this plus this, so we got this total. Now we go to circumference. That is more important. So we say, what is circumference? Here we will not multiply by A. Circumference is PIR, and that is, you can say external. External is 40. Internal is 30. So we'll write like this for reference, that external is R is equal to 4A. R is equal to 4A. And here also we'll say this internal, and R is equal to 3A. All right, so we now try to understand saying. So pi, you can say pi, and that is 4A. 4A says okay, fine. And it's also pi, and this is 3A. That's fine. We got external plus internal, sum of these two. We got this one here. Now extrusion. So we got parameter, internal, external. Now we say, what's about volume? Area. What area we had? That is rectangular area. You can say plane area, G into P. Let us say this is G. This is area here, total area, into P. P is here, I think extrusion is here. So we got this area, plane area, that is, we got G into P, and that is volume of curved portion, that is here F. Yes, this is F. Total curved area is this F, and we get here, F into P. P is extrusion. So we got volume of both separately. Now we got plane rectangular surface area, square meter. So 2 into end area plus parameter into D. So 2 end area, that is already G. I showed to you G before. Again, it's rectangular area, and we say that this is L into P, and L is here, L is there, and rectangular one, and P is extrusion. So we got this also twice into this and extrusion, and curved is here 2 into end areas O, circumference is O, external and internal. Now what we say, that this is 2 end areas plus circumference into D. 2 end areas, what is that? End areas of circumcurved areas. Wait a minute, maybe I made some mistake here. I should not make a mistake. Area, whereas total circumference is this, circumference curved is this, circumference curved external is this. Hold on. Total parameter is this. We got parameter, circumference, curved external, areas first of all. Sorry, I have to say areas first. Curved areas, there's that. This is total front rectangle, total curved area. Yes, this is area, and this is F actually. This is F because I'm taking twice total area square meter curved. So this should be F actually. This should be F rather. F. So we can make correction here. So it's that one. So it is. Yeah, that's what we miss sometimes. We make R. So this is that one. It's 2F. Let me be confirmed again. F is right or no? F. Total area square meter curved. So this is okay. This is okay. Fine. So that's here. Twice into this area. P into P into O. O is circumference, total circumference, so that's okay. I could say O into P or P into A, it's the same, no problem. So we got this one here. So these are, you can say, I can say this, all answers are bold, and these all answers also are total area. This and this are also bold. And if we say, we can take parameter as well as circumference as well, but it depends on, you will see later on, not to worry about that. Now I'm going to letter D. That's also a little complicated. Letter D. Sometimes complication is our friend, but once it is complicated, later it becomes workable. So already 7 o'clock, so it's not even how many hours, 1.5 hours. Oh, it's quite no problem. Okay. So letter D. You can say it's not difficult actually. You can see that one. This is D, like this. So 1, 2, 3, 4, 5, 6, and here is external and internal given. This is D. I'll show from my drawing. I'll show D is actually external is 24.82 meter, internal is 14.82 meter, middle one is 19.82. This is what it says. And then we have to see that we have here 6 areas and depth is 8a, whereas otherwise we have to see 1, 2, 3 areas are rectangular, and 5 area, 4 and 6 areas arced one, 5 is rectangular. So 1, 2, 3, 5 areas are rectangular, and we have here dimensions of this rectangle 35 and something, around we can say 3.5 and 8. So like this, we'll consider here in terms of curve one and rectangular one again, because curve one and rectangular again. I think these two D and G are last one in today's talk. Until I finish all others, I cannot present to you. Area 1, area 2, area 3, these are there. Area 4 is curved 1, area 5, then area 6 is curved 1. This is our consideration. Area 1 is 3.518A into A, conversion into A. Area 2 is 6A into A. Area 3 is 3.518 into A. Then area 5 is, area 5, curved line calculator, 8A minus 2 into 2.482A into A. And we say area 4, that is curve 1. Now it is, because it is D, quarter of a circle, it is 1/4 of a circle. So 1/4 of 2 pi r. When we say circle, pi d or 2 pi r is circumference. So 1/4 of that, 1/4 into 2 pi r into A. And that's r is equal to 1.982. That is 19.82. That is, we can say, in mid, because we are considering area, it's there in mid 19.82. So we are taking middle one, that's average of that. So we will use this formula for this. And area 6 is same way, 1/4 of, because it is D, 1/4 of 2 pi r into A. So also 1.982A. So let's do 3.518A into A, 6A into A, then 3.518A into A, and then we can say here 8A minus 2 into 2.482A and A. We got this. Now go to curved ones. This is 1/4 into 2 pi r, that's 1.982A, into again B8. So we same way, here we got this. So here total curved area and total other area. Curved area, sum of these 4 and 6, this is F and H, 4 and 6. And here we get curved area, and here we get other area 1, 2, 3, 5, 1, 2, 3, 5. We can say C, D, E, and 5, that is G. So we got bifurcation of both areas here. This is curved, this is that one. Now total is both, total for both is, this is just only for indicative purpose, not for using, because using is always separate for both. It's only for indicative purpose. Now we move on to parameter. Parameter. External rectangular, right? I have put them external rectangular, that is in one go, that is 2.518a, 6a, 2.518a, 6a minus 1.482. This is according to requirement here. Let us see. And this is external and internal both. Let us see external first. Let us see external first here. This is external. External, this is this. And internal is this. 3 dimensions here and 3 dimensions here. Let us see that, how it works out. Let us see external and internal. Now, we are taking here, parameter 3.518a, that's according to measurement. Leaving cover side plus 8a, which is vertical. So 3.518 is in the horizontal way into a. And 8a, that's 8a, 8 is vertical, and 3.518 again horizontal. So there are 3, and a, that's plus 8a minus 2.482a. Because that is on other side. 4th one. This one here. 1, 2, and 3 are continuous. This is for this area. We are taking this area minus this, minus this. That's what we are doing. Right? So let's go this way. Here is external, let us say 3.518a plus 8a vertical plus 3.518a plus a, plus 8a, that's other one, area 5, to say side 5, area 5 area, minus 2.482a. We got this value here, 3.518, then a, then 8, b, this 8a, and then 3.518. 3.518a, I think there's some error here, let's see, something may be wrong. 3.518 into a, 8a, 3.518a, 3.518a, this is actually plus 8, so this is multiplication here, 3.518a, this should be multiplication here, not sum. So I should say multiplication and remove this. So 8 then plus 8a minus 2.482 into a. So that's what it is. This is what we work for. You can say this is that. So again check 3.518a, 8a, 3.518a, 8a, minus 2.482a. So it's perfect now. 3.518, 8 here, 3.518 here, 8a here, and 2.482 here. It's fine, it's okay. That's what we expect you to do. So this is that one. Now that error of my plus has gone and been replaced by multiplication. So internal, let's see, 2.518a, let us see, 2.518a, 6a, 2.518a, and there's no plus here, right? 6a minus 1.48, we got this, fine. Some total parameter, this plus this, and we got this now. All right, now we move further, circumference. Parameter question is over. Now we are going to circumference portion. Curve portion is 1/4, 2 pi r. because it's which letter it is? It's this one. This is D. 2 pi r. Now we are taking these two for this purpose. So we are saying 1 over 4 because it's quarter of a circle. So 1 over 4 into 2 pi r into 2 r. R is equal to 2r is equal to this. Hold on. What I said. 1 over 4 2 pi r into 2. Okay, because 2 we are saying 1 here and 1 here. I think we are taking only one time outside, one time inside, so it's multiplied by 2. Okay, it's like that. So 1 over 4 2 pi r into 2, upper and lower actually I did not take separately, I just put 2 in, and r is equal to 2.482a, and similarly curved internal is 1.4 into 2 pi r into 2, up and down both. So this is 1 over 4 into 2 pi into r is 2.482a and multiplied by 2, and here same thing, I did same thing here as well and multiplied by 2, that's 0.25 into 2 pi into 1.482 into b, this one like this way. We did here 148, here it's different coefficient 1.482, that's depending on internal. So in external and internal circumstances is sum of q and r, we got this value. So our circumference and parameter have done. Now we'll see about 3D, this extrusion. This volume is J. We show J is the same thing as this, as J is this area. Okay, J is this area. Now we'll see J is this area. So I we multiplied by T here and we got this volume. Curved portion is T, is J also. Curved portion is J. How does this now? Curved portion, this is J here, and this is I. Yes, curved portion is I. Curved portion is I. This okay. So we got this also. We got this answer. Now plane rectangular surface area, that is the surface area. So 2 into end area. So it's J, and that is twice. 0776 it is. Let us see what is O is. O is here. Total parameter, this is fine. O is fine. So total parameters that we got this here correctly. Then we say is this surface area for, here it is particular D. So this value into D, and that's D here. That is T. So we got it. This is here T. So we got other one, curve one. 2 into end area, I is end area of that. I is end area of that, so that's I, is curve one is fine. And we got T. T is here, depth of extrusion, and S is total circumference. So we got this value. So these 4 values are done, and we can say areas are done here. Rectangular, not this perimeter, sorry, areas, total areas, that is rectangular, and this is that one, this one, both two areas are carved one. So just for our reference, I put them in. Now we'll go to G, which is last application today. G, and that is, G, that's telling something. I'm here like this, I'm your friend. It's very small actually. If you see this one, you can say it's like this, it's done like this. 1/4 here above and semicircle here. Area 1, 2, 3, 4, and 5. So outside is little point is also here. So we got this one here. So if you take AutoCAD clearly, you say which one is this, and this is this one. It says that its first rectangular length is 25, then its radius external 25, middle one 20, and inner 15. In all lower and upper one is quarter circle, and bottom is semicircle, and area 5 is 21. So that's what it says. So we'll move on to all these 5 areas. What these areas say. Now these 5 areas say strip width is same. Area 1 is rectangular, curved is second one, third is rectangular, fourth is curved, fifth is rectangular. This is what it says. That is 2.5 A into A, rectangular one, is then area 3, that is rectangular one, 8A, area 3, that is after quarter circle. So 8A minus 2.5A minus 2.5A twice after 9 multiplied by A. So that's this one, 8A minus 2.5A minus 2.5A, and that's that. Now area 5, that is, a half into A, this area 5. The slide will show which area 5 you're talking of. This area, this is that one. Area 5 is this a small one. This is a small one. Just for your information, be clear. Means what I'm talking of, very small, but area is area, small or big. So area 5 is here. Half into A. Half into A is there because his projection is like that. Plus half into A plus 2A into A. This is that area, half A into A plus 2 into A into A. That's what is. Now we are talking of covered areas. Covered areas, 1/4 is above 1, 1/4 because that's quarter 1. So 2 pi r, and AR is equal to 2A. I say that is R is equal to 2A because of 20, right? So it is, you may say, actually this comma is somewhere wrong. It should be 2 pi r into A. It should be 2 pi r into A. That is in bracket I use 1/2 pi r, and then we say A outside. So actually it should be multiplied by outside rather than writing A. It should be multiplication here by error is comma. So it's multiplication here, and then it is comma here. That's right. Okay. So we use that one. So we can say just it's okay, fine. So we say 1/4 2 pi r, 2r, 1/4 2 pi, and this is what is that? 1/4 2 pi into r, and r is 2A. So 2A and B is already there. So that's what it is. Again I say 1/4 2 pi, r is 2B, because 2A. So this is A, and then multiplication of A, we got this area. And then area 3, 8A, that's below curve, 8A minus 2.A minus 2.3, so this is 8A minus 2.5A minus 2.5 into A, we got this. Now curved area, other one, that is semicircular one, half of that, half of 2 pi r. Got it? Half of 2 pi r into A, and r is 2A. So we say this is half of 2 pi r, to half of 2 pi r is 2B, and this one we got this area. Half, this area 5 is half into A, plus this is half into A into A, half into A. I think I have done star mark on that. Let me correct it. Half into A. So it's half actually. It's not smart, so this is half. So this is our corrected one. So it's same as here, we got a mistake there, so it's error now free. Half into A plus 2 into A into A. We got this. Total curved area is 2 plus 4, this plus this, D plus E, D plus F we have, and 1 plus 3 plus 5 means C plus E plus G. We got both areas separately. Now we say rectangular one, because the total area of both is the total area combination is this, that is H and I, just for indicative purpose. Now perimeter, rectangular perimeter, and then circumference, and you can see perimeter how it works. We have to take perimeter of these three, we have to take perimeter of these three, but these two we have to take perimeter of all these sides. So rectangular is 2.5A plus 2.5A plus 8A minus 2.5A minus 2.5a, plus 8a, minus 2.5a, minus 2.5a, plus 1.5 into a, plus 2a, plus 1a, plus 1a, plus half a into a. This is, how many it is? You see yourself here. This is what it is, rectangular parameter. You can see these are here, and these are also there. Then this and this and this and this. So there are so many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with different dimensions. You can see 1, 2, 3, then 4, 5, then 6, 7, 8, 9, 10 dimensions are there, with variations, with varying dimensions. So it is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's plus and minus, all that. So we have checked it already. 2.5, and this is then 1. This is 2.5, and this is an 8. This is minus 2.5, and this is minus 2.5 again. And this is 8. This is minus 2.5. This is minus 2.5. This is plus 1.5. And this is 2. And then it is 1. Then it is 1. And then it's half. I have already done that, and result comes in this. And in curved case, it says there are 4. In curved case, circumferences, internal, external, both, there are 4. Curved M, that is 1/4 of 2 pi into r, that is upper one, and also r is 2.5a, other one is plus 1/4 2 pi r is 1.5a, then it's 1.1/2, 2 pi, that is r is 2.5a, plus half into 2 pi. So that's this one. That's this one, okay. So we have taken here 1/4, you can see this one, 1/4 2 pi into 2.5 this, and plus 1/4 again, like this here, and this plus half pi into this again, and half pi, this again. We have taken everywhere like this, and we got this answer here. Rectangular is this, and circular is this circumference. And now we go 3D here. 3D here, we got here 3D. So we can say volume is area, which is, I is area, let us see. I is area here, that's I area, and that is curved is H area. Is here, I area and curved H area. So it is I into M, that's this one, and curved is, that is H, and that is this one. And we got here rectangular surface, that is plain rectangular surface, 2 ends, and same as we did, 2 into I plus K into M, and K is here, parameter, and we can say curved surface is again 2 into H, H was its area, and L72, that's circumference here, into M78. So these parameters are created one, and this area we have created one. You got my point? And I like to show you again these sketches, because sketches are a little complicated one. These sketches are a little complicated one, and it took a lot of time to draw them. This is B and A, you can say. Of course, this is there, and you may say W. I'll convert W to inclined one also. I tried, but I couldn't find time for that. So it's W, V, it's U, it's T, it's S, and this is R, this is Q, and this is P, this is O, this is N, this is M, and this is M, and this is L, and also this is K, this is J, this is I, this is H, and G, E, and this is, this is D. Previous one also I'm just trying to reflect B, A, like that, and also others before that we did. This is star, this is rhombus, the star, both, and this is your diagonal, etc., etc., and all this. you're doing like this, and also you can say swastika, etc. But also, yeah, this is your motif, and here is, this is, you can say, this motif one here, and we go back and you'll find that it's star here, and it is combination of star with others. This is also previously done swastik and these like Shakti, and these combinations, of course, with this, and we did this one, this cruciform, and this David sign or Shakti sign. Like this, we have moved over to that one, and this here, others also previously. You can say that we have done that in different shapes, just for understanding mathematical geometry, for our purpose, and for purpose of all those who want to understand it in practical world, not in theory alone, not in books alone, how to use it for purpose of life, how to use it for purpose of life. That's where it is all about. You can see different designs, and here is that, like this, you can say. And these are very elementary diagrams here, very elementary one, which are used by everybody. Elementary mensuration, and you can say so. We have covered something, you may say, we have covered something of, calculation word. So that was my purpose. I'm trying to do more to cover up complete geometry of these letters, which is good one. You can just move again on this, standard applications, or you may call them formula, you may call them whatsoever you want to say. You can call them so, no problem to me. These are just, complete matrix is generated. So up to which level we have gone of this use of spreadsheet, means it's used in miscellaneous way, miscellaneous terms, but it's good that we are using it. That's important. So it's D and G. I'll do other one next time, and because it's already 2.25 hours, I do not pull more, and it's also 7.5. Well, I will thank you guys if you have attended this small video of 2.25 hours, or 2 hours you may say. I think it's a good one, and I will expand it further, including real shapes and many more later on. And I hope you enjoyed this. If you want to raise some question of formalizing, you can comment or you can write, up to you. If you want to write, my email address, that is suraj_engineer, SURAJ Suraj_engineer, ENGINER @yahoo.co.uk, or you can write in these comments also, no problem to me. If you want to raise questions, please send mail. I'll try to answer your questions. If you have something about formula formation in spreadsheet, I'm using for time being Excel. I have used Lotus 123 also, and I have not used Google. I'm just trying to do best on this. With this, I say thank you very much to all of you. Jai Bharat and Jai